Hello, 8th grade. This is your Module 5 review. All right, so starting with question 1, we define X as a year between 2008 and 2013, and Y is the total number of smartphones sold that year in millions. The table shows values of X and corresponding Y smartphones. So we have our X is on top, our Y is on the bottom. So question A says, how many smartphones were sold in 2009? So all you have to do is look for 2009, and the value below it is your value. Okay. Then B says, in which year were 90 million smartphones sold? So if we come number of smartphones, look to the right, 90 is with 2011. Okay, so then C says, is Y a function of X? Explain why or why not. So the way to tell if something is a function is if we look here at our X values, if none of them repeat, then we have a function. So none of these years repeat, so yes, we do have a function. All right, question 2. At NYU in 2013, the cost of the weekly meal plan options could be described as a function of the number of meals. Is the cost of the meal plan a linear or nonlinear function? Explain your answer, graphing if needed. So there's 2 ways that you can figure out this problem. So one way would be to figure out the slopes. So you do y2 minus y1 over x2 minus x1. And then you would take 2 of these. So your meals are your x, and then your cost is your y. So I'm going to take these 2 and these 2. The other way would be to graph it on your graph. Okay, so I'm going to do 135 minus 125 divided by 10 minus 8. This simplifies to 10 over 2, which simplifies to 5. So I just took the y2 minus the y1 over the x2 minus the x1. Now I'm going to do it for that second set of numbers. So I'm going to do 220 minus 155 divided by 21 minus 12. And remember, you have to keep your values together. So the 220 and the 21 go together, the 155 and the 12 go together. All right, I'm going to grab the calculator here. So 220 minus 220 minus 155. Oh. Is 65, and then 65 over 9, that simplifies to 7.2 repeating. So these values and these values are not the same. They don't have the same slope, so they're not going to be the same values. So if you're graphing them, so our values go from 8 to 21. All right, I'm going to do these in 3s. And then the symbol just means, and that's a bad symbol, the symbol just means that there's pieces of graph that I kind of scrunched up and that's not going to show. All right, and then I'm going to do these in 10s. So the first value we have is 8 and 125. So I'm going to come over here and find 8. And then go up about halfway to about 125. Our next value is 10 and 135. So I'm going to estimate this here at 10. And then again about halfway to about 135. Our next value is 12 and 155. So here's 12. And then I'm going to come up here to 155. And then the last one is 21 and 220. So I'm going to come over here to 21 and then 220. If I if I try to put those on, use a ruler to see if those connect, they don't really work. But they do have a slight curve to them. So if I connect these, there's a curve. So if we go back to the original question, is the cost of the meal plan a linear or nonlinear function? It is nonlinear, and depending on which method you use, either the slope, calculating the slope, or the graph, that's going to be your answer. Okay, so slopes aren't the same. Or the graph has a curve to it. Okay, so depending on which method you use would be dependent on your answer. All right, question 3 then. So it says list the formulas for the following shapes. So the circular cylinder, that has a formula of volume equals pi times r squared times h, or a more basic way is pi times the BH, which is the base, times the height. So the base, sorry, that pi doesn't go there. So the base is the circular base, and then the height. All right, so for the cone then, we have volume equals 1/3 times pi times r squared h. So if you remember, and let's look at these pictures down here, if I extend these sides down, this section is gone and this section is gone, so we're taking 2/3 away, so 1/3 is left, so that's how we get that one. And then for our sphere, we have volume equals 4/3 pi r cubed. And so all of these formulas you're going to be using on these next 2 problems. All right, so here we have a cone. So we're going to look up for our cone formula. So we have volume equals 1/3 pi r squared h. And then we can just substitute in these values. So I have volume equals 1/3 times pi. My radius is 4 times my height, which is 9. So if I come and put that in, I'm going to do 1/3 times pi, and you can use 3.14 if you want, times, and 4 squared is 16, so I'm just going to do 16 times 9, which should give you 150.796. So your volume is roughly equal to 150, and we're rounding to the 100th, so that should actually be 0.8 millimeters cubed. Okay, so we're rounding to the nearest 100th. All right, so this one we have a cylinder, so we're going to come up here and use this formula for a cylinder. So your volume equals pi r squared h. So our volume is pi, our radius is 2, that's squared, and our height is 5.3. Okay, so then I'm going to come over here again. I'm going to do pi, and I'm going to just calculate that 2 squared, which is 4, times 5.3, which is equal to 60.601. 66.6, and again rounding to the 100th, that would just be a 0. And the last one, we have our sphere. So volume equals 4/3 pi r cubed. So our volume is 4/3 times pi, our radius is 3 cubed. So our volume then, so I'm going to do 4 divided by 3 times pi. 3 cubed is 27. So I'm left with 113.097. So if I round that to the 100th, I get 113.1 inches cubed. All right. Last question. All right, you want to fill the cylinder shown with water. All you have is a container shaped like a cone with a radius of 3 inches and a height of 5 inches. You can use this cone-shaped container to take water from a faucet and fill the cylinder. Okay, so we're assuming that the cylinder is, maybe it's out in the yard, maybe you can't move it. It does have small dimensions, but let's just assume that you can't bring it to the sink. So we're using the cone-shaped container to take water from the faucet and fill the cylinder. How many cones will it take to fill the cylinder with water? So we have to find the volume of this cylinder, the volume of the cone, and then divide. So the volume for the cylinder is pi r squared h. And then, so let's figure that out first. So we have pi, our radius is 8, and our height is 3. Okay, so let's come over here. So we're going to do pi times 64 times 3, which is 603.1. Let's round that to 19. Okay, and then we're going to do the volume of the cone, and that is 1/3 times pi r squared h. Okay, so we have 1/3 times pi. Our radius for the cone is 3 inches. And then our height is 5 inches. So this comes out to be, so 1/3 times pi times 3 squared, which is 9, times 5 is equal to 47.12. And then we're going to divide that. So I'm going to take 603.19 divided by 47.12. Grab our calculator one more time. 603.19 divided by 47.12 is roughly equal to 12.8. And then we can technically have partials, but this would be an example where we would round. So we would need 13 cones to fill the cylinder. So that is the last question. Please reach out if you have any other questions. Make sure you bring your review and your calculator to the test on Monday. Good luck and have a great weekend.